to say is, yeah, it has become an annual thing, and what I'm going to talk about is essentially do a review, and that's you know, not a bad thing to do every year. It's just since you don't necessarily deal with this kind of storm over the course of the entire year, it's good to do a review at the beginning of the season. We'll do a summary of last year, and then we'll I'll just go through some operational issues at the Hurricane Center, how we get our information out to the users during these storms, and we'll finish off with an outlook for the 2013 season. So what is a tropical cyclone? Well, a tropical cyclone is essentially a large, relatively large weather system that doesn't have any fronts, kind of like the weather systems that we usually see here in Canada. They form over the tropics or subtropics, and they're essentially an organized area of thunderstorm activity. And one of the key features for an area of thunderstorm activity out in the Atlantic Ocean to be considered a tropical cyclone is a closed center of circulation. In the top image here, this is a tropical depression. There's actually a closed center of circulation right here, and then it evolves into a tropical storm when the winds reach at least 63 kilometers per hour. And then if the winds exceed 118, that's when it actually gets classified as a hurricane. And then once the storm, the winds associated with the storm exceed 178, that storm or hurricane gets classified as a major hurricane. And of course, there are 3 categories or 5 categories of hurricanes, which I'll cover in a sec, but 3, 4, and 5 are considered major hurricanes. And we've never had a Category 3 hurricane make landfall in Canada yet, since the records go back to 1851, but we've come close a few times. Another thing that happens to these storms as they come up, and we'll talk a little bit more about this later, is that they actually transform into what looks more like a storm that we see in our latitudes with cold areas and warm areas, or in other words, they have frontal areas, frontal zones that cause most of the weather. So we'll take a look at that later. So why do they form? Well, the whole purpose of a hurricane is to take excess heat that's stored in the ocean and then pump it up into the atmosphere. The image on the left-hand side here is essentially an infrared satellite image of water temperature in the Atlantic Ocean as of just a few days ago. And you can see in the tropics and in the Caribbean and into the Gulf of Mexico, the red area is essentially the warm water. And up here over Canada, you can see the blue colors there indicating that the water temperature is quite a bit colder up here than it is down there. But over the course of the summer, that water just keeps heating up and heating up and heating up. And that heat, that energy, has to be dispersed in some way, and nature does that through the formation of these tropical cyclones. So the warmer the water, everything else being equal, the more storms you're going to get, and the more powerful they're going to be. So what do they look like? Essentially, if you look at them from space, at least in the more developed storms, they have a nice circular pattern to them with these spiraling bands spiraling into the center of the storm. And if you take a cutaway or a cross-section of the storm, you'll see all these successive bands as you're heading towards the center of the storm. These clouds get higher and higher, so those bands are stronger and stronger. So as you're going towards the center of the storm, or if the storm is approaching you, you'll get these bands of rain and wind getting stronger and stronger, with little breaks interspersed between the bands. And then the worst conditions are right in the eye wall of the hurricane. That's where the tallest thunderstorms are within the storm. And in fact, in the storm, in the eye wall, the thunderstorms that make up the eye wall actually tilt outward a little bit. Yep.
In the bands, like you said, you get breaks in between.
Yeah.
That breaks in the rain or also breaks in the wind?
Well, both.
Both.
Yeah. What happens when you get these downdrafts, the strongest winds in a hurricane are just a couple of thousand feet above the surface, whereas the strongest winds in, say, a winter storm are up in the jet stream. When we get these thunderstorms actually moving over an area, that helps bring those wind gusts down to the surface. So you'll get heavy rain, gusty winds. Not to say that it's a total break in there that the weather's nice. You might still get the odd shower, but it won't be as strong as when you're in a band. You'll definitely feel the bands as they're going over.
Yeah, I was aware of the bands of the clouds, but I didn't actually realize there was updrafts and downdrafts.
Yeah.
With each successive band.
Yeah.
That's
Yeah. Yeah.
The 117 number or the
speed
numbers? Is that like a 3-second or a 5-second burst of wind?
It's a 10-minute average.
10-minute
a 1-minute average, sorry. Yeah, the 1-minute average at 10 meters.
Is there a typical band about the gust, like standard deviations away from that average?
It's not sure the answer to that, but you get higher gusts towards the center of the storm, so that difference tends to be a little bit more as you get towards the center of the storm. There are other things happening there as well that contribute to very high wind gusts as well, but we're getting into something a lot more complicated than this.
I have one follow-up question. The building code uses 5-second gusts as their wind measurement.
Yeah.
Would you be able to even track any of that for a hurricane in the past?
There are conversion factors, because a lot of our monitoring equipment don't necessarily take the 1-minute average. So when we're looking at marine buoys or ground weather stations, we have to actually do some conversions to determine what the maximum winds are within the storm to fit the definition of the storm.
That was my last question. I have one more. The rain gets stronger as you go in. The wind gets stronger as you go in too. So when you're taking your measurement, are you measuring at the core or are you measuring? Because I thought the wind was.
Well, you want to measure. I mean, you don't always have a say in where you take the measurement. You like to find the area that has the strongest winds. So when they fly into it with an airplane, they'll try and determine where the strongest winds are, and then they'll drop a sonde around that area to determine what the strongest winds are.
Thank you.
Yeah, no problem. And speaking of our airplanes, this is a picture of from a hurricane hunter as he's punching through the eye wall, and you can't necessarily tell on this image, but I mentioned that the eye wall actually tilts outward a little bit. So when you're punching through there, you're going through these, usually they fly in at 5,000 or 10,000 feet. And the stronger the storm, the stronger the updrafts, the higher they fly up, because they don't want to be too close to the sea when you're getting these strong updrafts. So they'll go in about 10,000 feet, and then, I mean, it's a really, really rough ride when you're punching through the eye wall, and then boom, you break out, and it's nice and clear and calm, and they call it the stadium effect. Because the sides of the storm, the eye wall, are tilting outward, it looks like you're in a big stadium. It's a very odd feeling to actually punch through a hurricane, a major hurricane like this one. So the typical life cycle of these things, you'll see later where they form and at what time of the season. But this is kind of a generalized representation of where they form and how they form and where they go. You'll have a little system develop off the coast of Africa. There's no discernible center of circulation that I mentioned earlier until 5-6 days into the life cycle of this thing. And at that point it gets a number, and then it gets classified as a tropical depression. And if conditions are favorable for the system to continue to intensify Then about a week after formation, and it reaches tropical storm category, or the winds of at least 63 kilometers per hour, it's at that point that it gets a name, and then it keeps that name throughout the rest of the life cycle, whether it becomes a hurricane or not, and then eventually into what we call a post-tropical storm, or a storm that has fronts, but started off as a tropical storm.
Bob?
Yep.
Correct me if I'm wrong, but this first named storm of the season got its roots in the Pacific. Was it not a Pacific storm that jumped Central America and reformed?
Yeah.
That sounds like an oddity to me. Is that?
Yeah, it happens every now and then, but when it weakens, like I think it was Barbara when it was in the Pacific, then it weakened over over Mexico, and then the center of circulation actually made it back out over the Gulf of Mexico, and then it re-intensified. But when it made it into the Gulf of Mexico, it didn't have the criteria for a tropical storm at that point, so it didn't have a name, even though it was the remnants of I think it was Barbara. So when it redeveloped as Andrea.
Quick question. If you have one essentially center catching up with another, if they combine, which I know is rare, but it does happen, how do you determine what the final name is?
When a storm actually two systems combine, it would usually be in the post-tropical phase, which at that point we don't necessarily name them at that point. So if we can identify that the original circulation, the original center of circulation is still the dominant center of circulation, that bigger storm system will maintain that name as a post-tropical storm throughout. If we can't, like it happened, I forget the name of the storm, but a couple of years ago, where we had the storm come up, and it combined with another center of low pressure just off of New England, and then that center re-intensified. That center just didn't have a name because it was a separate center of circulation. They usually don't combine in the tropics, which is the trickier part of that scenario. So what do they do when they approach Canada? Essentially, there's a couple of things they can do. They can weaken as they get cut off from their source of energy, which is the warm water, so either moving over land or moving over colder water. They can, as you mentioned, they can merge with another system and weaken, or weaken and then merge with another system. And then every now and then they become what we call post-tropical. So they transform themselves into what looks like more of a winter storm with respect to the structure of the storm. And then they can weaken and as a post-tropical storm, but every now and then we get a storm that actually re-intensifies and re-intensifies significantly as a post-tropical storm. And the term post-tropical is a Canadian coined term, and it's now in the lexicon of tropical cyclones, which is actually, it's quite interesting that, and you'll see why later, because this is where it happens most often. But there's some discussion around maybe the term post-tropical is misleading because people think it's an after-the-fact storm, and they may not pay as close attention to say a post-tropical storm as they should, and I'll have some examples why later. So when they do become post-tropical, and this is something we do every year to make sure people understand this, as a purely tropical system, the winds and the rain are pretty much symmetric around the center of the storm, and there's a couple of things that happen to all this when the storm is becoming post-tropical, or what we call extratropical transition. The wind field actually expands, so the storm gets bigger. The maximum winds may not be quite as strong, but the storm gets bigger, and the rain shifts to the left-hand side of the track. So if we're dealing with a post-tropical storm or a storm that's towards the end of the transition, you may not see rain on the right-hand side of the track at all, but that's where you'll get most of your wind, and we'll talk a little bit about that later, and all your rain will be on the left-hand side of the track. So, a little bit about the climatology. The season runs from June 1st to November 30th, and there have been tropical cyclones in the Atlantic in all 12 months of the year, but you can see there it really starts to get going in August as that warm water reaches its peak into September and then October, and then it starts dropping off after that. And you can see where they develop early in the season, as opposed to as we get into the peak of the season, and then it kind of peters out a little bit when you get into October, November time frame. Of course, the Hurricane Center in Halifax, we monitor every tropical system that's out there. However, we don't necessarily issue information statements on all of them. We just concentrate on those that will have some sort of an impact on Canada. And this is our response zone. And here, whenever we expect the center of circulation to cross this line within a roughly a 72-hour period, we start our regular routine bulletins every 6 hours. Even beyond 3 days, we'll issue a bulletin or two about 5 days out, every day. 5 days out, 4 days out, and then 3 days out, we go to every 6 hours.
Has the trend been the season starting earlier, do you find, or is it still staying?
Yeah, it's still pretty much. I mean, the last couple of years we've had storms early in the season, but if you go back and look at some of the data from years and years ago, yeah, there have been other cases when we've had the season start early. Last year we had 2 named storms before June 1st. So. And we typically get a 2 or 3 actually transiting our marine area and 1 or 2 affecting our landmass here in Canada. And I mentioned this transition to a post-tropical storm, and some work that was done a few years ago to determine where you're most likely to find that. And it's right off the coast of Atlantic Canada is where you're most likely, if a storm of tropical origin tracks within a certain distance from you, the likelihood that it's going to be post-tropical is highest in here. And kind of the same data, but expressed another way, this black line is the 50% line. So anywhere north of this black line, which is pretty much everywhere in Canada, if you get a named storm, it's likely going to be post-tropical, or it's going to be going through that transition, about to complete the transition and become post-tropical. So I'll talk a little bit about some of the hazards, and the main determining factor for storm intensity is wind, so I'll start off with wind. If you take a storm, you have the air rotating around the center of the storm, which is essentially the wind associated with the storm. And if the storm is stationary, you get a southerly wind on the right-hand side of the track and a northerly wind on the left-hand side of the track. The 2 wind speeds are roughly the same. However, a lot of these storms, most of these storms, are moving. They're going somewhere. And sometimes they stay stationary, but most of the time they are moving. So if you look in the direction the storm is going, the air is rotating around it counterclockwise. So the storm is going in this direction. The wind on the right-hand side is actually going in the same direction that the storm is. And if you look at the left-hand side, the winds are going in the opposite direction. So you have to, when you're looking at the winds revolving around the center of a hurricane, you have to take into account the hurricane speed as well. So on the right-hand side, you have to add the speed of the storm to the winds that are rotating around to get the actual winds that you're going to see, and you have to subtract the speed of the storm on the left-hand side. So you end up with a storm that has slightly stronger winds on the right-hand side in the case of a purely tropical system. So I give the example here. If you have a pure hurricane in the tropics, and the winds are rotating around the center at 150 kilometers per hour, but the storm is only moving at 10 kilometers per hour, so you do that math, you end up with 160 kilometers per hour on the right-hand side versus 140 on the left-hand side. So a little bit of a difference, but essentially damaging winds on both sides of the storm. However, if you remember that map that I had with the black line, where most of the storms that we get are in that post-tropical or transitioning phase, that means that those storms are accelerating and they're moving quite quickly. So you end up with a much bigger difference in wind speed on the various sides of the storm. So in the case of a post-tropical system, the actual winds rotating around the storm may not be as strong as the pure hurricane, in this case, for example, 115 kilometers per hour, but the storm could be moving at 50 kilometers per hour, which is quite reasonable for a storm going through this transition. So if you again do the math, you end up with 165 kilometers per hour on the right-hand side versus 65 on the left-hand side. Huge difference in wind speed, damaging winds on one side, non-damaging winds on the other side.
So in that case, Bob, I mean, you could have a post-tropical hurricane coming up tracking to the east of Newfoundland.
Yeah.
And so you could have a post-tropical storm, no longer a hurricane, and have 165-kilometer winds in St. John's.
If the center is to the west of St. John's, yeah, you could have that. I mean, I chose numbers here to really illustrate the point, but that's essentially what you're looking at. And if we're forecasting a track going, say west of St. John's, then we'll have all kinds of tropical warnings. We'll have wind warnings, and if the track actually just goes to the east, St. John's, huge difference. And they'll be expecting maybe 130 kilometers per hour, and they may get 60. And everybody's going to say, oh, it's a big bust. But it's just that little...
So in our industry, things get really interesting when you have wind damage and you've got 165-kilometer-hour winds, and people are telling us it's not a hurricane.
Yeah, well, exactly. Yeah,
right?
Yeah.
So that's...
Yeah. So, and that's the point where when we talk about post-tropical, a lot of people think it's nothing to worry about, it's after the fact, and whereas you can get, sometimes if you're starting off with a weak tropical system, the post-tropical version of that can be worse than the actual tropical version of that, and we've seen examples of that as well. Yep.
I think it's kind of ingrained in the public mind that if there's a post-tropical storm, the thing they most have to worry about is the rain.
Yeah.
What you're pointing out here is that you can get hurricane winds or force winds.
You can get hurricane force.
That can be pointed out. That can be pointed out in a forecast or a warning saying you are going to be getting hurricane force winds of such and such potential.
Yeah. Oh, absolutely.
Luckily for us, Canadians, usually inside of the track.
And I think it was I was looking at my notes from the briefing last year, and I think, Daryl, you had asked me about the climatologies of winds on the right-hand side of the track. Was it you?
Maybe.
Don't
remember.
I did some digging around and to see what kind of distribution there was of winds on either side of the track, and this is a examination of the storms that have actually entered the Canadian Hurricane Center response zone, and a clear indication that for most of the time, the strongest, by far the strongest winds are on the right-hand side of the track, and in fact, if you want to drill down a little bit more, mostly they're in the southeastern quadrant of the storm. Is where you'll find the strongest winds associated with the storm. So assuming the center of the storm is right here, strongest winds will be to the southeast of the storm, climatologically speaking. And this is another representation of where you're going to find your strongest winds associated with the different types of storms. The blue line is, and this is an example from Charlie in '86, and it was work that was done by Evans and Hart, which is the same two people that did the study to find out where you're most likely to find tropical or post-tropical storms. And the zero mark right here is essentially the center of the storm. So how far out from the center of the storm are the maximum winds. So you can see in the center of the storm, in the eye of the hurricane, if you will, it's calm, and the winds are very light. But once that eye wall moves over you, then the winds shoot right up, and then it's only about 50. This is in miles, so 50 miles from the center for this particular storm that the strongest winds were. So the strongest winds associated with the purely tropical storm were very close to the center. However, if you look at the red area, the winds in the center of the storm are actually, they're not starting off at 0, they're starting off at 40, and again, this is miles per hour. The maximum winds aren't quite as strong, but then it extends out a lot farther than they do in the hurricane, when the purely hurricane, and that's when the storm is becoming post-tropical. The red line is when the storm is becoming post-tropical, and once it's reached post-tropical, the maximum winds actually extend out to about 300 miles from the center of the storm. So that's a clear indication that the storm is getting bigger. The maximum winds are spreading out from the center of the storm, which is a classic case of what we see when we see this post-tropical transition stuff. And again, Canada is where this happens most often. Looking at rainfall, again, I mentioned where the rainfall is to the left-hand side of the tract as opposed to the right-hand side. And the amount of rain depends on a number of things. The size of the storm, the motion and duration are kind of tied together. Rainfall rate, we've seen in these storms some incredible rainfall rates associated with these types of storms, and the stage of transition. That depends where you're gonna see your actual rainfall. If it's just starting transition, you'll probably see rain on both sides. If it's post-tropical, you'll probably just see rain on the left-hand side. And a good example of that is Ike back in 2008. You can see where the storm made landfall in the Galveston area, and this is a representation of rainfall, and the black line is the track. So you can see very heavy rain associated with the storm on both sides of the track. That was when the storm was purely tropical. And then it weakens somewhat, and then it kind of intensifies again, but as it's moving up the Ohio Valley, but as it's coming up here, most of your rain now is on the left-hand side of the track, and actually at some point there's no rain on the right-hand side of the track at all. Sometimes there's not even any cloud on the right-hand side of the track, and when there's no cloud, and it's during the daytime and the sun heats up the ground, it actually makes the winds, which are on that side of the track, even stronger. Another hazard associated with these types of storms is storm surge. And essentially storm surge is the wind blowing the water on shore, and you end up with a rise in water level on shore. There are other components that contribute to the height of the storm surge, but by far the biggest component is the wind pushing the water on shore. And things that determine the size of the surge are things like wind speed, wind direction, the size of the storm, which we'll see a bit later, and the coastal bathymetry, or essentially how the ocean floor slopes up towards the coast. And here in Canada, it slopes up fairly steeply compared to, say, the Gulf of Mexico. And the Gulf of Mexico is a very shallow increase right up to the coastline, and they get phenomenal storm surges in the Gulf of Mexico. And this is an example of the backyard of Kimberly and David King in a place called Waveland, Mississippi, and this was taken just not too long prior to Hurricane Katrina. This is their backyard, nice tree there, nice lawn, and as I transition over to the after picture, keep an eye on that tree, and that was what was left after the storm surge. The storm surge with Katrina actually reached 26 miles inland, and you never know what's in the water. So one of the things that struck me is the nice green lush lawn that they had. Now it's all pretty much most of the vegetation is dead, and you can see some debris up in the trees there. This particular house was 4 blocks from the Gulf of Mexico, so everything in the whole area just got obliterated. And you can see that even the vegetation took a hit in that particular storm. And if you go, they actually have a website, and they show this particular property every year since Katrina, and it's still there's not a whole lot down there. The lawn has become green again, but that's about the only change. Another hazard that is unique to these types of storms here in Canada is that they can generate some very, very high waves, higher than you would even see in the tropics. Because when a storm is actually blowing over a certain area, it generates waves. Those waves actually move at a certain speed, depending on the depth of the ocean and all that. In the case of an extratropical or a post-tropical storm, those storms are moving quite rapidly. They actually outstrip the waves, so it generates waves, and then it moves out ahead, and the waves kind of lag behind. So if we get a big fall storm, winter storm, we'll get the storm flowing through, and then we'll get the waves lagging behind a day or so afterwards. In the case of the tropical system, since it's moving so slowly, it actually generates the waves, but the waves actually move out ahead of the storm. And that's how they used to tell in the Caribbean that a storm was coming, is that on a nice sunny day, the swell would start to get bigger and bigger, and they start to get big waves crashing on shore. They knew that a storm was coming, and then the waves were kind of a warning that the storm was coming. So now you take these two cases of a storm that's starting out moving very slowly, generating waves that move out ahead of it, but then you take that storm and you start that post-tropical transition or extratropical transition. What happens to the speed of the storm? Speeds up. So now it starts to catch up with the original waves that it was generating, and then you end up with a certain period of time where part of the storm is in perfect sync with either the whole area of waves or just a small portion of the waves, and they're in sync and they can be in sync for 12 hours, 24 hours, and what happens there is that the waves just build and build and build. And there was a lot of theories about this phenomenon occurring, but it's 20 years ago, almost 20 years ago, when we started to observe these things. And there's a lot of work that's been done on this particular phenomenon at the Hurricane Center. And one of the things that we saw was some phenomenal waves in the marine or ocean buoys that we saw out there, that even some of the forecasters couldn't believe that the waves were getting that high, until we had the QE2, the luxury liner that actually was going from Europe to New York and actually got caught in the waves associated with, it was, I think, Luis at the time back in '95. And in a distance about just a few hundred kilometers, went from 2-meter seas to 29-meter seas in a luxury cruise liner. And because it happens that fast, it goes from reasonable seas for the North Atlantic to 100-foot waves in a very short period of time. So turn that around, then what we have in Atlantic Canada, when we have these storms coming, is people want to go, especially when we start talking about waves, people want to go down to Peggy's Cove, and they want to go everywhere along the coast and watch the waves, but they don't understand that they may be standing, 50 feet back from where the waves are, but if you start to get some of these larger waves, it won't take very long. The waves might be going 50 feet behind you and wash all these people into the ocean. And we've seen cases of that in Maine and in Nova Scotia and Newfoundland as well. So this is a very particular phenomenon, because you need the case where the storm starts off slow and it speeds up to catch up with the waves. And again, that kind of stuff happens at our latitude. So this is a particular hazard for Canada that they don't necessarily get down in the tropics. So just kind of summarizing the threats, with general depiction here, Nova Scotia, you got your heavy rain on the left-hand side, strongest winds on the right, and because you have your strongest winds on the right, you'll get your storm surge and largest waves there as well. So we'll look at what happened last season. Last year was another busy season, and you can see the forecast that came out last year called for 9 to 15 named storms. We actually had, or 9 to 15, yeah, and we actually had 19. With respect to Canada, we had 6 that entered the response zone, and 3 actually affected land. And in that forecast from last year, they expected an El Nino to develop into the hurricane season, midway through the hurricane season. That never really materialized. Whenever you have an El Nino, that tends to keep the numbers down. So we never did really get that El Nino, so that's why the numbers were a little bit higher. You can see the tracks of the various storms throughout the year. I'm gonna go into a couple of storms here because there's a few lessons to be learned. But storms I won't get into are things like storms like Chris, that became a hurricane, entered our response zone and kind of did a loop on itself. And there was Nadine as well that set a record for the 4th longest lasting hurricane in the Atlantic Ocean. It formed in early September and lasted into October. And Nadine is somewhere in there. It zigzagged. It kind of had a very odd track to it. So I'm just going to play this little, again, I showed this last year, and seems to be something that kind of neat. Essentially, the entire hurricane season in about 4.5 minutes. It's just a satellite representation of the season. So at the top, the number there is 5 is the month, so it's the month of May. So as I mentioned earlier, we had 2 named storms before June 1st, before the season actually got going. And now 6 were in the month of June. Things were fairly quiet in June. We got a few extratropical storms going through even at that time of the year. Now usually this particular representation, there's Chris that did a little loop on itself and then headed off. This particular representation is done by a collaboration, I should say, with NOAA and NASA, and usually they actually have most of eastern Canada on this, but they cut it a little too tight this year, so you just see the southern Ontario, not quite southern Quebec, and the southwestern tip of Nova Scotia. So now we're into July. You can see as we get into July, even though there are no named storms, there tends to be a bit more activity in the tropics as the water gets warmer. Mid-July. July wasn't too bad. Now we get into August, Ernesto, the E storm, and Florence. And so now you're starting to see things really starting to get going. Some just stay offshore, which is fine with us. And Isaac, I'm going to talk a little bit more later, but Isaac tracked into the Gulf of Mexico, made landfall in Louisiana, fairly close to where Katrina made landfall. We have Kirk and Leslie, which I'll talk a little bit about as well. because Leslie did have impacts here in Canada. Leslie just kind of stalled here for a few days and before it decided to get going. And then here's Nadine on September, early to mid-September. And then Nadine just kind of stays out there for almost a month, 28 days or something like that. This is not Nadine. Nadine is still off the map here. But it went up, it came back, it went up, it came back. Luckily, it stayed out here and not into our response zone, because it would have severely taxed our capabilities to issue messages on this thing for something that lasted 28 days. Now we're into October, and then we have Raphael that actually generated some of those large waves, and I'll talk a little bit about Raphael. And essentially, it was mostly a Newfoundland event, not a huge event, but still. Then Tony, and then finally Sandy. Sandy, of course, was the storm of the season. And as you can see, the cloud pattern gets bigger, and as it's becoming post-tropical, and now we're into November, and then that was pretty much it for the 2012 hurricane season. Go back to the...
Bob, when you make a forecast for an active season, or more active or less active than average, is there any attempt made to distinguish between landfalling hurricanes or just hurricanes in the general area?
Yeah, there's no real attempt to try and at least not from a NOAA perspective.
So it's conceivable you could have above average hurricane season without any making landfall?
Absolutely. Yeah. The forecast for the season is essentially an estimate of the number of storms that will form in the Atlantic Ocean. It says nothing about where they're going to go. And I have a slide here towards the end that shows, at least for Canada, and it's same applies for the U.S. You could have, say, 19 storms in the whole Atlantic Ocean, not one of them make landfall. And it's still from...
And around the table here, we would think it was a nothing.
Yeah. Which is why it's, looking at it in reverse, it's important to understand what the forecast really means, and that it's the estimate of the activity in the Atlantic Ocean, but not necessarily where these storms are going to go. Now, there are agencies that actually do try and predict which area of the U.S. are going to be affected, but the science is just not there to have a credible forecast of, this is, there's some private companies that were out there saying, the East Coast is going to be affected by storms. They say that every year. So there's, if you say it every year, obviously it's going to become true at some point. But the science really is not there yet to say which area is going to be affected. There's some work to try and determine that, but we're not quite there yet. And that's why it's probably a good idea to keep issuing the seasonal forecast, so that at some point where we are capable of saying, well, maybe this area is more susceptible or that area is more susceptible. One of the things that's and this is just on the kind of periphery of where the science is right now, we look at pressure anomalies in the Atlantic Ocean, and if we have generally lower pressures off the east coast of the U.S. in the May to June time frame, or around this time, there's a propensity for the storms to curve up kind of as opposed to going straight into the Gulf of Mexico. But again, that's kind of out there, and it's something that, at some point we might be able to do, but right now is not there yet. So I'll look at a few storms here, and the first one is Isaac. Isaac tracked into the Gulf of Mexico, made landfall in Louisiana towards the end of August, and you can see all the rainfall here, because as the storm was tracking up, and it was a tropical storm throughout most of its life, became a hurricane just prior to landfall, and then was quickly downgraded again to a tropical storm. But then the storm kind of stalled out here, and they had close to 700 millimeters of rain in quite a short period of time, caused all kinds of flooding. There were 34 fatalities associated with Isaac, not all of them in the U.S., but as the storm was out in the Caribbean, $2.35 billion in damage, and the perception was that, hey, this is just a Category 1 storm, perception being from the people in Louisiana, that, hey, this is just a Category 1, it's, you know, we've dealt with storms like Katrina, this is going to be a lot weaker than Katrina, and essentially there was massive flooding associated with this storm, which is understandable given the amount of rain, but this is New Orleans up here in Mississippi, and a lot of the dikes in the area had some work done on them since Katrina to kind of build them up a little bit, but some of the systems down here, no work had been done on them at all after Katrina because this area essentially didn't flood during Katrina. However, with Isaac, again a Category 1 storm, all this area flooded out, and if you remember watching the news when Isaac was going through, we saw a lot of the same images of people having to go up in their attics with an axe and bust a hole through the roof and then get rescued from the helicopter from the top of the roof. So I found it quite interesting that, you know, for people in that area who, you know, have dealt with Katrina, they kind of brushed the storm off as being, it's just Category 1, and a borderline Category 1 at that. And it just goes to show that you have to really kind of dig into the forecast and try and get more information on the details, because it's the details that are going to eventually cause all the impact. So in this particular case, knowing that the storm was going to stall and produce all this rain, it was something that would have been in those forecasts that they would have seen. Now, the other storm I want to talk about is Hurricane Leslie, and Leslie, as we saw in the satellite loop there earlier, formed out in the Atlantic and then kind of stalled south of Bermuda before it started going again, and then eventually made landfall near the Burin Peninsula of Newfoundland on September 11th. We were dealing with stuff in Nova Scotia as well. You can see the center of Leslie over here, and we had a frontal boundary pretty much that moved slowly across Nova Scotia, well, the whole Maritimes at the time, and there was some moisture, not necessarily directly associated with Leslie, but kind of indirectly, that was riding up on this frontal boundary, and since it was going so slowly, we had flooding from Yarmouth all the way into Cape Breton, and the Truro area, which, you know, usually floods in even lesser amounts of rain, saw some flooding as well. As opposed to Newfoundland, that got mostly wind damage. Western Newfoundland got some minor flooding damage, and in Nova Scotia, because of that other feature. This is just an example of Truro, and the other images are the wind damage in Newfoundland. And this particular picture made it around. Most of you've probably seen this picture, but there's a story behind it. The idea was this guy had his Corvette and he was building a little shed to store the Corvette in, but the shed wasn't completed. And he didn't want to put the Corvette in the shed because the shed wasn't ready, and he said, I'm just going to put it on the downwind side of the shed, and of course the shed blows over and topples onto the Corvette.
Try. Say thank you when the insurance history box. And a new shed.
Yeah. Then we have Raphael. Raphael became, you can see the nice comma-shaped cloud pattern, which is indicative that the storm has become post-tropical, or at least was in the process. So that phenomenon I talked about earlier about the waves building and building, that's what actually happened. The storm actually curved out towards the northeast, so it didn't actually, it actually tracked quite a distance away from Newfoundland, but there's still, you know, once these waves get generated, once the storm starts accelerating, the waves keep going in a straight line. They don't necessarily follow where the storm is going. So the waves just moved out and then eventually crashed on shore, and there was, they say, about $1 million in damage associated with waves. So you can't really see the sky in this image, but there was clear blue sky, there was no wind, there was just all these waves just started to crash on shore. And now, again, the storm of the season obviously was Sandy. Sandy formed south of the Caribbean towards the end of October as a tropical storm, tropical cyclone, so purely tropical at that point. And then it tracked through Jamaica and Cuba as it tracked northward, became a major hurricane. At the Hurricane Center, we started our messaging pretty early in the game, started discussions with emergency management officials shortly after the storm was actually formed. And then the storm made landfall on the evening of the 29th. We started to get our first media around the 24th, so the Wednesday, and it just kept ramping up from that point on. And then again, this is beyond the 72 hours that we would issue our 6-hourly forecast, but we started issuing 5 days ahead of time our messages twice a day, giving an update on the storm, where it was. And then we started having our emergency management briefings, and we had a media briefing on the Friday before, so we wanted people to know what to expect as we headed into the weekend. We've seen a lot of times where people just go through the weekend and they don't pay attention to the weather, and then when the storm happens early in the following week, they're kind of caught by surprise. So we wanted to make sure that people were monitoring this storm throughout the weekend, and then again, like I say, it eventually made landfall on the Monday evening, the 29th. So you can see it started the transition to post-tropical a lot farther south than you would typically see. If you see a storm going through transition early in the season, it usually starts somewhere up here. The later you go in the season, the farther south that transition actually starts. So here in Canada, we had wind warnings posted for Ontario and southern Quebec. We had special weather statements for the Maritimes because there wasn't going to be a huge event for Atlantic Canada. And again, as the storm became post-tropical, the wind field expanded, and as you remember, it was a very, very large storm. The winds actually reached 1,600 kilometers from the center of the storm at its peak when the storm was the biggest, and we saw the damages there along the shore of the U.S. There were 147 direct fatalities from the Caribbean up here to Canada, $74 billion in property damage, making it the second costliest storm, second only to Katrina. At the peak again, 9 million homes were without power, especially in the U.S. Some was for several weeks, and of course recovery is still ongoing. This is just a representation of southern Ontario, where we had wind warnings out, and a screen capture that I made the next morning of the power outages here in southern Ontario, so it meshes quite well as to where we had wind warnings and where some of the damages were. The patterns affecting Sandy, you remember that curve right into New York was a bit of an oddity there. We had a low pressure system out in the Atlantic Ocean, and we had this huge dome of high pressure in the northern part of the North Atlantic. Storms generally won't punch through high pressure systems. Those high pressure systems, especially one this strong, will either deflect it, will actually cause these storms to stall, or to deflect them on one side or the other. And all our models showed this area of high pressure really not moving a whole lot over the course of the week leading up to landfall. So we figured, well, the storm has to either head over, go to post-tropical, and maybe merge with this system. And if that occurred, it would be purely a marine event and nothing to worry about too much, or it was going to be too far away from this and would actually come up and be deflected up. So there's two scenarios we were looking at, even a week before the storm actually made landfall. And the computer models actually painted the same scenario. The white track here is the track the storm actually took. And this particular one, this track here, which doesn't show the whole track, actually this was the European model, and this track from day one had the storm making that curve up into the eastern part of the U.S. All the other models we were looking at had the storm actually going offshore. So there's some conflicting information as to what we thought the storm was going to do, and that was 7 days out. 6 days out, the European model was still painting the same scenario. At this point, 6 days out, where it actually makes landfall, we don't want to start pinning that down. That's way too early. However, what we're looking for is what kind of scenario is going to happen. Is it going to make that curve, or is it going to head out? Now, 6 days before, some of these models that had originally forecasted the storm to go east out into the ocean were starting to slowly come back towards what the European model had. And then 5 days out, all the models started to converge, and we knew at that point that our friends to the south here were in for a storm that probably most people in that area had not seen in their lifetime.
In the insurance community, there's a lot of talk about the European model and how it did so much better. So
Yeah.
do we know why it did so much better?
They're still looking into it, and they've just to kind of balance things out, they've looked at a whole bunch of storms during the past hurricane season where the European model was out to lunch, and where some of these other models were the models that actually turned out to be right.
If I could hazard a guess to answer that question, Glenn, I would say that the Europeans spend a lot more time looking at weather patterns above 35 degrees north of the equator, and I would suspect the Americans don't.
Would you say that's largely because of European winter storm mimicking hurricanes so much? And
it's north of 35, right? Whereas the traditional hurricane belt in the United States is south of 35.
Yeah. Although some of the like the GFS model is usually a model that's pretty good and is built to handle things north of 35 north. Even our Canadian model had the storm going offshore 6 days ahead of time, and in that 5 to 6 day time frame is where it started to make that adjustment. But there's probably some papers to be written on how and why the European model handled this particular case well, while the others in the early part did not.
And what new information came in day 6 that made the day 5 models also different?
It was more of a gradual thing, because this would indicate a track that was going to go right into that area of high pressure, which we knew wasn't going to happen. So either the models didn't initialize well with that area of high pressure. The area of high pressure was either going to weaken, or it was going to move significantly to the east to let the storm come up here, or it's something within the initialization of the models that picked up on something that the European model picked up on and started. We interpreted this as not a plausible scenario, but rather a shift to this scenario. So even though this was better than this, we just took it as, okay, the models are starting to adjust, and we knew 6 days out that the models from the next day were going to be very interesting to see what would come of it. And then that's what happened the next day, is they all started to come together. And once they came together, it was, I mean, they stayed together for the rest of the event. And that's the track, but the models, all the models had the storm, and what was important is this re-intensification as a post-tropical storm. That was the key thing through all of this, is that re-intensification. You don't see re-intensification to that degree very, very often. All the components came together at the right place at the right time, and you had that very, very strong re-intensification after the storm, after it became post-tropical. And of course, it made landfall in New Jersey in the evening of the 29th. Some of the weather parameters, this is the track, and you can see the rain. At that point, the rain was pretty much on the left-hand side of the track. As the winds were on the right-hand side, the actual numbers aren't quite as important as the actual strongest winds. So the red numbers are the hurricane force gusts, and you can see that most of the strong winds are to the right-hand side. And the storm was so big and it covered an area so large that it started to draw in some cold air, and that's one of the things that helped the storm re-intensify. But there was just, at that time of the year, there was just so much cold air available that some of the mountain areas in Virginia and North Carolina actually got upwards of 2 feet of snow with the storm. Yeah.
So I thought the hurricanes you talked about take the heat from the ocean and power it through.
Yeah.
The post-tropical storms need cold air to get stronger?
Yeah. Yeah, cold air on the to the west of the center of the storm. So what drives the storm as a post-tropical storm is the difference in air temperature between north and south. Bigger the difference, stronger the storm. So you can imagine we're taking a storm that takes its energy from the heat that's stored in the ocean to a storm that takes its energy from an air temperature difference between north and south. So there's a lot happening when they're going through transition.
And is that why it speeds up too? Because of the...
it speeds up because it starts to interact with the jet stream, and the jet stream kind of pulls it apart, but also makes the center move a lot faster as well. And this is just a representation of some of the damage associated with Sandy from FEMA. And most of the areas here, combination of wind damage and storm surge, but you can see how far the damage actually extends, which you wouldn't see if this was a pure hurricane. You just wouldn't see the damage that widespread. It was widespread because it was post-tropical and it was so big.
First, with the damage in Sandy, I don't even know the answer to this, but I know that it seems for a long time after the event, you were still hearing stories about apartment buildings with no electricity and people living without heat because they can't get their furnaces replaced.
Yeah.
Is any of that still existing? Are they still? What's the state right now?
Oh yeah, there's still areas and neighborhoods that just aren't inhabitable. They're still working on it, cleaning it up. There's large areas that had like power generation stations or substations. It's not a matter of the telephone pole being blown over and having to replace the pole. The whole substations were under seawater, which means that the whole thing has to be replaced. And it was just
And that's an important distinction is seawater, salt water, as opposed to fresh.
Yeah.
I also can shed a little light on that. I was talking to the emergency manager, one of the emergency managers down in New York, and again, one of the big problems in the lower part of the city is everything was underground. All their phone lines, all their power lines, everything. It wasn't just, the water washed over it. If the water flooded all of that and was there for quite a long period. Actually, in some cases, some of the lines were supposed to be resistant, but when you flood the thing for a week, the resistance starts to go, and they lost so much that some of these areas that are still, most of it's recovered, but the odd place is not well plugged into the grid or wasn't particularly well built, so it took more damage than others, and it's just taken time to fix everything.
Because we lose track of it a week after the event.
Yeah.
The real interesting thing is I talked to some people down in Playa del Carmen who get hit by hurricanes quite often, and they've buried all of their infrastructure right along the shorefront. And I saw this and I sort of went, "Are you nuts?" And they went, "No. We've actually, they what they've done is they put a lot of effort into hardening the cabling and hardening all of the tunneling and so on. So, and also because of the actual rock and soil, the water drains away really, really quickly. So it's kind of different that down there, if you get a hurricane, they flood, but it immediately drains, and their systems are hardened so much that they just come back up almost immediately, even if they're right beside the shoreline. So much different from New York, which just
Yeah.
went down and in many cases stayed.
Yeah, yeah. Well, especially with the building, you know, all along the shoreline. I mean, and they had never seen something like this in quite some time. I mean, it was, when you build right on the shore like that, you're kind of setting yourself up for some major damage. This is another slide that I got off a FEMA presentation, and it represents the public assistance costs in New York, and you can see how it compares to the 9/11 terrorist attacks. And even other than the 9/11 terrorist attacks, all these other events are all kind of weather-related events, so it just goes to show. But it was interesting how it kind of dwarfed all the other events.
They announced today, I don't know if you saw it, Bloomberg, New York City's gonna do a $20 billion plan to build dams and dikes all around.
Oh, yeah.
They got 900 and some miles of coast, they say, which I thought was a lot. I didn't realize it was that much.
Yeah. Guess if you take into account Long Island
Yeah.
and all that, it could add up, yeah. And there's just some of the pictures from, and then there was damage down to the even Florida up into the Carolinas. And this is starting in New Jersey, so these 4 images are in New Jersey. Yeah.
So, the damage that Katrina did in Miami, at that point, the storm was a hurricane.
Yeah, yeah.
But Florida was not receiving the hurricane force winds.
I
Because
don't
it's on the
think,
left side of the track, and it's a long way off,
I don't
right?
think they got into hurricane conditions and.
So it's interesting, they got relatively mild winds,
Yeah,
but technically it was a hurricane.
yeah, yeah,
And in New York, the winds were much more severe, but it was not a hurricane.
yeah, yeah. Well, the maximum winds associated with the storm, when there was the minor damage in Florida and a bit more substantial damage along the Carolinas, the maximum winds weren't occurring where the damage occurred,
Yeah.
but they were there in the storm. And they were probably a little bit, they were stronger than the maximum winds when the storm made landfall.
But
But the
those weren't the
storm-
winds attributed
Yeah.
to the damage, though.
Yeah, exactly, yeah. So as you go up the coast, this is New York, and then into Rhode Island, Connecticut, and even up into the Boston area, you can see some of these waves, how big these waves got. And you keep in mind that the storm actually made landfall here, and you're getting those kinds of waves up in the Boston area. So it gives you an idea of just how big that storm was, and on the right side of that track, and even to a certain extent to the left as well, because there was just so much water. Storm was so big, pushing so much water on shore, that if you, and kind of following on what you just mentioned, with regards to post-tropical and hurricane, in Halifax, 10 years ago, we had Hurricane Juan. We had a 1.5 to 2 meter storm surge associated with Juan, a Category 2 hurricane. A post-tropical storm resulted in a storm surge of 3 meters. The peak was 3 meters, but it ranged quite a bit. But goes to show, you know, even if you have a post-tropical storm, the fact that it's so large, and if it makes that landfall pretty much at a right angle, all that water piles up at the coast, and you have what you had there. Yeah.
How come, is there a weather reason for the purple, the red, the yellow, and then there's a green off, and then there's another yellow?
Yeah,
and there's
it's,
a green, and then there's a yellow. Is there a weather reason for that, or is that social building?
Well, I think it's probably more of a social type thing than the weather, although, if we're talking in the mountains,
Because you got Cleveland there in yellow, right? I think that's what you're referring to.
yeah, well, see, Cleveland, on this side of the storm, the winds were from the north, so there's probably some coastal damage along that, just like around in the Sarnia area, we recorded something like 7 meter waves in that area of Ontario, just because the winds were straight down over the lakes and creating that.
I think you can see some social and also data issues there. We see a nice perfect line, right, and red on one side and yellow on the other. At least either the storm or the weather knows political boundaries or data issues.
It's all being done by county.
One's Democrat, one's Republican.
Right, exactly.
And then some impacts here in Canada, the wind damage, of course, here in southern Ontario. And this was what the waves were doing in Halifax. So I showed you the waves in Boston. Even up in the Halifax, we did get some waves associated with Sandy. And further down the coast of Nova Scotia, we had up to 9-meter seas crashing on shore with a storm making landfall in New Jersey. Quite phenomenal. Of course, some of the challenges, it's been, quite highly publicized of the Hurricane Center in Miami's procedures that if once a storm becomes post-tropical, they no longer have jurisdiction, if you will, on that particular storm. They are no longer the experts on that type of storm. So a storm that starts off tropical, they handle all the messaging in the U.S. Even when it's going through that transition phase, they will still issue messages on it. But once it's declared post-tropical, that's it. They pass it to
Or the Canadian.
Weather Center in Washington. But you make a good point there about the Canadians, because since, remember, a number of slides ago now, that black line where we get most of the storms that we get are in that post-tropical phase. We never had that procedure. In fact, we had the opposite procedure where if a storm becomes post-tropical, we will still issue messages on the storm, and we will still issue tropical type warnings, so hurricane warnings and tropical storm warnings, even though it's a post-tropical storm. Now, if it's several days or beyond 24 hours, say, that the storm became post-tropical, then we won't necessarily issue tropical type warnings. But if it's, say, within 24 hours, we'll still issue tropical type warnings, which they didn't do in the U.S. The problem is they never had to deal with a storm that was declared post-tropical 2 hours before landfall. So you had the storm coming up. All the TV meteorologists out there were saying, well, there are no hurricane warnings. It's all coastal flooding warnings, wind warnings, all this stuff. But it wasn't, because the Hurricane Center in Miami, from day one, expected this storm to be post-tropical at landfall. So the National Weather Service, they all got together and they came up with a strategy of how are we going to handle this? Do we break the procedure, deviate from the policy and issue tropical type warnings for a post-tropical storm, or shall we go by the book? And they decided to go by the book, and they got a lot of flack for it, because some people think that if there had been hurricane warnings in effect for that area, that it may have incited people to get better prepared and to evacuate when they needed to evacuate. So they've actually adjusted their procedures this year, starting this year, and we've consulted with them, and they've consulted with us, as we do every year on a whole bunch of other things. But we've provided them information on how we do things, and they may have taken some of that into consideration when they adjusted their procedures for this year. And of course, it has, from what I'm told, has major implications in the insurance industry, which maybe you can enlighten me on after the presentation is over. But that's one of the important things of this year, and they've actually used that already with Andrea. Andrea was declared post-tropical well to the south. The Hurricane Center in Miami kept the messaging until it reached well into New England. So I spent a lot of time on Sandy, and the reason why I spent a lot of time on Sandy was because just what we just talked about is that it was post-tropical at the time of landfall. And that's where we're most likely to see one of these storms come up, is as a post-tropical storm. Because at that point, the storm is no longer driven by the ocean temperature, it's driven by that difference in air temperature. and we get a lot of differences in air temperature here in Canada, so that's what drives these storms once they come up here. So a typical worst-case scenario would be, a late-season storm like Sandy come up and re-intensify dramatically, and if it hadn't been for that area of high pressure, that storm would have probably made landfall further north, either in Atlantic Canada or into New England, or further north into New England, which would have, given the size of the storm, would have had a much bigger impact on Atlantic Canada, southern Quebec, and here as well. So one of these storms could easily affect us, and thinking that this is just, this is something that they see in the U.S. and not here, doesn't apply for the post-tropical storms. A few other interesting facts about Sandy. It was an unprecedented storm for media at the Hurricane Center in Halifax, just because it was going to affect such a highly populated area in the U.S., and it was going to affect southern Ontario to southern Quebec. It was certainly a record breaker. The previous record for media was Isabel back in 2003. And during Juan, for example, we had over 200 media requests. We had over 400 media requests for Sandy. The 911 call center in New York, they were at their peak getting 20,000 calls per hour. They had to they designated 5 people within their call center to answer emergency calls via Twitter. So it was the first time that they've documented in the U.S. that they were getting emergency calls via social media. We saw the picture earlier of the storm surge in Mississippi. Well, during Sandy, 11 billion gallons of raw sewage was dumped into various eastern U.S. waterways, so you have that environmental component as well. And some of the waves generated by Sandy actually got registered on some Richter scales across the U.S. So moving on to just a few items on operational responses to these things. At the Hurricane Center, like I said, when we expect a storm to cross that response zone within a 3-day period, we go to issuing bulletins specific to that storm every 6 hours. And this is kind of a general business cycle of what we go through in that 6-hour period. The bulletin, the track map, all that stuff goes out at 8 a.m. Eastern Time. And we give emergency managers in the affected area a few minutes to go over the bulletin, and then we'll have a WebEx call and talk about the storm. During Sandy, we had emergency management officials from Ontario all the way to Newfoundland, so it was a very, very large call when we have these storms affecting a lot of different jurisdictions. We'll also have a call with the Government Operations Center in Ottawa. They bring in all the different federal departments, and they have their own call, and we give a little briefing on the storm. We do a lot of internal coordination with other weather centers, and there was a lot of that during Sandy. We were talking to the military forecast stations. We were talking to the Ontario Storm Prediction Center, Quebec Storm Prediction Center. There was a lot of people on those calls as well. 11 a.m., but 11 a.m. to 12 is where we start to get some new information on the storm and start updating the weather bulletins. If the storm is going to have a big impact in Canada, we would usually have a media technical briefing around noon. We bring in the media and we explain to them what the storm is doing, where it's going, and then open it up to questions. That's usually about an hour. And then we usually have a blackout for the media, at least have an hour to prepare the new bulletins that go out at 2, and then the new cycle begins. And the media briefing is typically once a day when we do those things. Yeah.
Cool. I'm assuming for the emergency management officials in Atlantic Canada, getting a call from you guys and watching the weather is a pretty regular event, and you have procedures, and that all works fine.
Yep.
How was the introduction of Quebec and Ontario and the bigger meeting? In my head, I have a picture of you talk to them, they talk to their people, the questions come back, and there's a bit of a loop, and maybe even goes to the Premier's office to brief them, and they want you want to. So if you do it in provinces, how is it for 6?
It's it certainly had its challenges on the technical side and on the logistical side as well. I'll talk a little bit about how that information flows in the next couple slides here. And of course, I'm sure you've seen some of the bulletins. We have two bulletins, a public and a more technical bulletin that goes out. And you can see those on hurricanes.ca, and you can actually sign up to get them sent to your email address. Every time a hurricane bulletin is issued, you'll get it on your email, hurricanes.ca. And the forecast track map, we made some major changes to it last year, and this year, see this blue was a bit darker blue, and this year this is what it looks like. Any kind of weather agency gets all kinds of comments from the public and comments and complaints, and I'm sure you can well imagine. Some of the ones that we got related to the hurricane map was the color that was chosen for the ocean was too dark, and you couldn't see the track well enough. So we've made some changes this year, and so that was good criticism, and we've been able to incorporate that into the changes for this year. So if you go to the track map, this is what it looks like this year. And
have you ever had requests from the private sector, and specifically sometimes insurance companies, well, obviously insurance companies, to have more direct data earlier during your tracking period, or more instead of just the bulletins, or just, you know what I mean, to have a little more input, a little more information from real-time data?
Yeah, I don't remember getting any requests specifically on that. I mean, there's stuff out there that's, you know, especially if the storm is, you mentioned earlier in the game, there are websites out there that have different information that you wouldn't necessarily get from us, but it's still out there, and you can go on to Google Earth now, and you can monitor the temperature, the wind, and all this stuff from the Hurricane Hunter aircraft. You can track it, and it's within a couple of minutes.
Mm-hmm.
So you know, as he's going through the eye wall of the storm, you know he's in the center of the storm. It's phenomenal, the information that's out there, but it's all different sources, so yeah.
Yeah, I think one of the things that would be concerned about from an insurance point of view is more from the claims. The sooner the insurance company knows that some place is going to get schmucked, the sooner they can do a claims response. And in some cases, many companies have a catastrophic claims response unit. They can get it out there, they can get it set up, or at least be ready to get it set up once the hurricane's gone through, because I don't think you necessarily want to be sticking that right in the middle of an actual hurricane.
Yeah.
But you can end up with a faster response if you get that information earlier.
Yeah, I can concur with that. I mean, we're in that field, and that's what we heard from some of our insurance clients.
So what kind of information would you need for that? Like a map showing the impact areas?
That would be really useful.
Yeah, because the problem is, like, you can get PCS data, which is more historical data, where they track and the history and all that. But that's like past, and that's good for underwriters or whatever, or risk managers to predict future. But the thing is, from a claims point of view, we go, of course, you can go to Environment Canada's website, like radar pictures. The problem with radar pictures, unless you go there at the time and somehow you have to save them, because sometimes we want to go back to track, okay, where exactly did that storm track to apply to an insurance when you get the claims and see, okay, which ones are most likely or whatever. You can't, because those radar pictures, unless you were there and you were saving them, they're gone.
They're actually there now.
They're there now. Oh, yeah. But are they accessible to public? Actually on the website? Okay.
Yeah.
I'm aware.
I think that's the key. There's so many different sources you get.
Yeah, it's
not a
difficult to
centralized
navigate that website.
source.
Yeah, it's some of the things that are being worked on, and we don't necessarily have them on our website now, but if you go to the National Hurricane Center website, they have some new products that they're working on that shows you where the strongest winds are going to be and where the heaviest rainfall is going to be. And that's something that we're working with them on, because they're showing stuff coming up into Canada as well. So they haven't stopped at the border. So that's something that is being worked on between the CHC and the NHC as well.
I was gonna save this for later, but I might as well ask you now. You mentioned in the past that, they're trying to reduce the cone of uncertainty. How's
Yep.
that work coming along?
That's exactly what I have up there now. Great time. Great timing for the question.
You give me $20 later.
Yeah. The way the cone of uncertainty is constructed is you, when you forecast the track of the storm, you forecast positions at different points in time, going out to 120 hours, which is 5 days. And what they try and do to construct an area of uncertainty around that point of where they forecast, they go back and look at every forecast that was issued for every storm going back 5 years. And they look at they take an average of the distance, and they take 2/3 of that radius to come up with their circle of uncertainty around a specific forecast point. So to illustrate that in an example, if at a certain point in time, say for this case 72 hours, we expect the center of the storm to be over Toronto. What that actually means is that there's a 67% chance that the center of the storm will be anywhere within that circle. Firstly, there's a 33% chance that it might be outside this. So people look at the cone and they say, well, it's going to be within that cone for sure. But it's not for sure. It's a 67% chance. And if it deviates from the curve, they say, well, the storm veered off. Well, the storm didn't veer off. It was always going where it was going. It was the forecast track that was a bit too far on one side or the other. So that's kind of the distance. That's what you kind of should be, and I didn't include beyond 72 hours, but say 72 hours. This year's error for 72 hours is 237 kilometers. If you look at 48 hours, it's still, fair distance. And then 24 hours out still, you could still have the storm track well to the south of Ontario. Those numbers are actually, they usually go down every year, and these numbers represent a 8% decrease in track error from, say, last year. 8% is quite a bit in a year, a good improvement in a year. You won't always get 8% every year improvement, but it just so happens that the storms that we had last year were, reasonably well forecastable, and that's why that cone got smaller. So you take all these different circles and you join them up together, and you end up with the cone of uncertainty. If you're looking at the track, well, you got to be thinking, okay, it's 67% chance that it's going to be within the cone, or 33% chance that it's going to be outside the cone. So, and this is probably one of the biggest misinterpretations of hurricane-type forecasts that there is out there, is in these tracks and what the cone actually means.
But that's the center of the storm track that you're bringing the cone, right?
Yeah. So we do all kinds of briefings with the media. We usually, when NOAA issues their forecast for the season, we'll issue, rather than just do media for days, we bring them all in, do it all in one day, and then that's it. And of course, when we have hurricane briefings, when we have actual storms, we'll have hurricane briefings if we expect significant impacts over Canada. With respect to our emergency management folks, we do these kinds of briefings as well. We do a seasonal briefing. We've done all maritime provinces, and we have a couple more to do before early July. And then there's this briefing as well. Actually, when there's a storm on the go, we would actually, like I say, start our briefings usually 3 days prior to the storm's arrival, or when the emergency management officials say, well, we need it a bit earlier. So we would start those briefings, as I mentioned earlier, 15 minutes after the morning briefing goes out. We do it via WebEx. And this is kind of to your question earlier about how the information flows. We start off with that briefing in the morning, either done by myself or Chris Fogarty, who's the program supervisor at the Hurricane Center. And it's just for the provincial emergency management offices and the offices of Public Safety Canada. Because when we started doing this, everybody wanted to be on this call, so it kind of got under control, so we needed to kind of coordinate things a bit. So we have the first call, which is usually most or all the Atlantic provinces. If we have a storm like Irene 2 years ago, or Sandy, where we need to bring in other provinces, we'll do that as well. So any area that might be affected, provinces affected, we include them as well. And so it's just a kind of a general overview of the storm, where it's going, what kind of forecast difficulties are there, any uncertainties. Sometimes, like we saw with Sandy, all the models are pointing in the same direction, and, you know, we're pretty confident that it's going to go a certain way. Sometimes they all point in a different direction, and that kind of information is useful to the emergency management folks as well.
So you had 5 days out, you're tracking, and you start this process.
Yeah.
So for a Sandy storm, when did you call Ontario?
Was the
5 days out when you
we started these briefings on the Friday, which would have been the 26th or 26th. Our warning preparedness meteorologists, Jeff Colson, Peter Kimball, just started the discussions with EMO Ontario, I think on the Monday or the Tuesday, so a week before. Yeah. And there would be discussion throughout the week, and then just like we did with the media, where we wanted people to know the information as we're going into the weekend, we wanted to have our first briefings on that Friday morning. So we brought everybody in. One of the technical issues that we had is my particular WebEx account had a limit of 25 people, and we busted that like in the first call, and so I had to upgrade to 200, and we certainly needed that throughout the rest of the storm. Now, once that briefing is done, and that's the Canadian Hurricane Center Hurricane Briefing. Again, the Government Operations Center in Ottawa, they listen in, but they don't ask questions. And then the regional offices of Public Safety Canada and the provincial EMOs are on that call. If a particular province is going to be affected, then we have another briefing shortly after that, which we widen it up a whole lot more. So the say for the provinces that are going to be affected, the briefing is hosted usually by the emergency management agency in that province, along with the warning preparedness meteorologists, who would in this case be Jeff Colson or Peter Kimball, and Jeff or Peter would actually give an update on the storm. And on this call, you'd have the municipalities, you'd have critical infrastructure, provincial departments that have a role in emergency response, that type of thing. So a lot more people on this call than on the previous call, but just to make sure things are coordinated, that you don't end up with a call that lasts an hour and a half. We've broken it up in these types of things. Some of the information out there in terms of what we can provide. I mentioned about the impact maps. This is something we have out there now, and I don't have the address on here, but there's an Environment Canada GeoMet site on Google Earth, and you can go on there, and if there's a hurricane that's active, you can click on the Canadian Hurricane Center track, and you'll get the track and the wind radii, or the radius of the strongest winds, or these different category of winds that extend from the center of the storm. If you Google GeoMet VMS Environment Canada, you'll eventually get there. If you want that address, I can provide that as well. I don't have it with me, but if you send me an email, I can do that. So if you go to Google Earth, you'll get our track on there with the Canadian version of the cone and the wind radii as well.
And actually, if I can draw attention to that, the wind radii is actually important for
Yeah.
Canadian exposures, I mean, you were asking the question about how you track this and how you figure out where you're gonna put your response units in. Well, that's sort of what I do, but I don't do it for you, I do it for our clients. And when I see the cones and where the tracks are gonna go, I've kind of developed some algorithms to say, well, that's where the center of the storm is, but, and I've coined my storm damage track.
So it was you that brought that up last year.
And I shifted to the right.
Yeah,
And you shift, the further north you go, the further you gotta shift it to the right,
yeah,
right? And that depends on the speed of the storm and a bunch of things. So my methodologies are a little crude,
yeah.
but at least
But I'll give,
I'm shifting my storm track to my storm damage track.
Yeah.
And then I'm superimposing that on my clients' portfolios.
Yeah.
And that's where the maximum wind damage is gonna be, not the storm track. And
Yeah.
the further north you go, the bigger that deviation
Yeah.
is. And again, it's what your priority is. If you're looking at wind damage, you wanna shift it to the right. But if your concern is flooding damage, you wanna go way over to the left, right?
Yeah.
So you've got different priorities. And so if you're looking at your response purely on where the storm track is, you're never gonna be right on either count.
Right.
And if you go to the NHC site, they have maps in, like georeference data for maps showing probability of the wind exceeding, say, tropical storm strength. Probability of the wind exceeding 50 knots, which would be warning criteria here in Canada. Or probability of the wind reaching hurricane strength. They have all those probabilities on there, so you can actually go and figure out what the probability is. And those models take into account the right-hand side of the track being the windiest and all that. So it helps in providing information on which areas are going to have the highest probability of getting the worst conditions.
Yeah, and it's always a dance to analyzing all the data and getting out a timely response.
Yeah,
right?
That's issuing forecasts. That's, we look at all the stuff and then at some point we gotta cut it off.
If you wait till 6 months after the fact, you can always give the right answer.
Exactly, yeah. So we're gonna be playing around with social media. We did a little bit of that last year. We do have some challenges there to get stuff up out in a timely manner. We don't have a specific CHC Twitter account, but there is an Environment Canada Twitter account, and we can send stuff out there. We're also going to be trying to do stuff on YouTube where we actually take part of those emergency management briefings or media briefings and we put them on YouTube. So we're going to be playing with that this year, so keep an eye out for that. So just in finishing here, this the forecast for this season, and this forecast was issued about a month ago, and no other calling for 13 to 20 named storms, 7 to 11 of those becoming hurricanes, and 3 to 6 of those hurricanes actually achieving hurricane status, and you can see how it compares there to an average year. So all the factors that we look at to try and determine how active the season is going to be, they're all pointing in the same direction. They're all saying it's going to be an active year. It's when you start to get conflicting information, and you know, one thing that we look at is pointing towards a busy season, but then the other is pointing to lesser storms. So everything this year is pointing in one direction, and that is going to be a busy year. So we'll see. When I'm standing here next year, we'll look at how things actually go. When I mentioned, when we were talking earlier about the number of storms in the entire Atlantic versus the storms that actually have an impact on land, there's all kinds of comparisons in there, but you don't have to go very far. Just looking at the last 3 years, we've had 19 named storms in each of the last 3 years, but the red bars indicate the storms that have actually entered the Canadian response zone. So in 2011, we had 8 named storms. That was a record-tying 8 storms that made it into the response zone versus 6 last year. But then you look at 2010, we only had 3 storms that made it into the response zone, even with 19 named storms. But on the other hand, the storms that we did get in 2010, those were 2 landfalling hurricanes with Hurricane Earl and Hurricane Igor. So even if we get fewer storms, if you get, you know, fewer storms, but those storms are bad, it can end up being a bad season as well. 2010, when we had the two landfalling hurricanes, they had none in the U.S. So, that's never happened before. So the names, we've already used Andrea, and then the next one will be Barry, Chantal, all the way down. And Sandy, next time we use the list that was used last year, Sandy was retired, the only named storm that was retired last year, and it was been replaced with Sarah. And I'll just finish with this. There's an old adage in emergency management where you have to be careful what you exercise, because if you exercise a scenario, you've essentially condemned that scenario to actually happen for real. And there's two cases of that in last hurricane season. I was actually down in Orlando in March of last year and talking to some people who were involved in this particular exercise, where they had a major hurricane, Hurricane Gisbert, which was named for one of their retired emergency managers, come up right around the time that they had the Republican National Convention in Tampa towards the end of August into early September. And this exercise was going to take place in early May last year. And they had 70,000 visitors, 15,000 of those actually being media because they were there for the convention. And lo and behold, as Mitt Romney was getting ready to accept the nomination, up comes Isaac, and there was a lot of concern with Isaac, that Isaac would actually disrupt the convention. They actually had to make some changes to the schedule for the convention. They did get some heavy rain and wind, but it wasn't really that damaging. And then a little more eerie is a case where they exercised a fictitious storm that came up in October '97, and it was based more or less on the 1938 hurricane that caused a lot of damage there, wind damage and storm surge damage. The storm was going to make landfall in an October evening, and of course, guess what the name of that storm was? 97.
Sandy.
Yep. Going back to 97, someone actually made a screen capture. You can see the old Netscape browser there. And back then, the track only went out 3 days. Now it goes out 5 days, soon to go out 7 days. But you got bulletins and maps here for the storm. And again, this was 1997. And they actually did an exercise on a hurricane named Sandy, and all these years later, we got the Hurricane Sandy. So with that, I'll open it up to any other questions you might have.
Thank you. Thanks.
So everybody knows on Thursday, September 19th, we're holding our second Basement Flood Symposium, Board of Trade, full-day event. So if you're interested, talk to Tracy about it.
Just a comment. I was thinking that maybe post-tropical storm, someone could, I think you alluded to this, maybe change the name to extra-tropical storm or come up with something that, you know, that people don't say, oh, it's only a storm. Terminology quite often is everything, and the way people view something as everything, you know.
Yeah, it's something that was coined here in Canada. Actually, we coined it at the Hurricane Center, and it was since accepted into the lexicon of tropical, and we use it every year, and actually in some of the bulletins that you see coming from Miami, they use it as well now. But this is the first year that we've actually started, and I think it was largely because of Sandy, that maybe that term is maybe not the best term, because it makes me think of a storm similar to Sandy, Noel, back in 2007, which was a very intense storm that went through transition early in its stage way down in the south, and got very, very large, very intense, and made landfall in Nova Scotia. There was an editorial in the newspaper in Halifax where this woman was talking to her mother on the phone here in Ontario, and her mother was all worried about the storm, and she said, oh, there's nothing to worry about, it's post-tropical, it's an after-the-fact storm. So if that's what people are getting from the term,
Yeah.
it may be something that
Yeah.
needs to be looked at
Implies that
again.
it's over.
Well, yeah, well, post is, kind of after, the term post-tropical, it's after it's tropical. So it's no longer tropical, but
That's not,
that's how it was thought, but it,
Interpreted as post-storm.
yeah, if that's the way it's being interpreted, then it may be something.
call it an Atlantic typhoon. Doesn't mean anything, you know, but
Yeah,
just name it itself would get people's attention, and that's
yeah,
what you want.
yeah,
Kind of the analogy, I know, in the insurance perspective, when you have an earthquake, it's not the time the earthquake's the most, where you get the most damage, it's the aftershock
Yeah.
that happens, so it's kind of, same analogy.
Now, one of the things that was explained to me is the differentiation between hurricane or tropical and post-tropical and the impact that it has on insurance claims. And the way it was explained to me, and correct me if I'm wrong, if a storm is, and the example that was quoted is if you had a $500,000 home in along the shore of the U.S., and it was hit by a tropical type storm or hurricane when it was tropical, your deductible would be a lot higher than it would be if it was not. So the declaration to post-tropical of Sandy 2 hours before landfall, huge impacts. Is that?
That's right. Yeah, hurricane deductible would have kicked in, it would have been multi-thousands of dollars per home versus typical deductible.
Wow.
And we don't have that up in Canada, it's not.
Yeah, but
Wind is wind in
it
Canada.
was just a post-tropical storm.
An after-the-fact storm.
It also has reinsurance implications as well.
Oh, right, yeah.
I'm not sure about that. Wind is wind in insurance.
Mm. But in some cases, the definition makes a difference.
Depends on some of the pools, that's in the States, the wind pools.
Well, yeah, 18 states have wind pools, but, any plans for 10th anniversary one?
I have a slide here, just, I won't go through all the stuff here, but this is just a list that I made of some of the changes now versus what we had before one. And there's a number of things. A lot of it has to do with communication, and we never had these media briefings before. We never had these emergency management briefings, and it's been refined tremendously since then. In terms of one of the things that logistically, the Hurricane Center used to be on the 19th floor, the top floor of Queen Square in Dartmouth. During Hurricane Juan, the building, which is designed to do it, was actually, shaken a little bit. But when you're on the top floor, it's like being in the back of an airplane when you're going into turbulence. You feel it a lot more if you're on the top floor than if you're on the lower floors. So people were actually getting nauseous up there. That was one thing. But when the power was out, they could only pump water up to the 7th floor. So because of fire issues, we couldn't work up on the weather center. So since then, we've actually moved down to the 3rd floor, so no issues there anymore. You can see some of the forecast track errors, how they've been reduced in the 10 years since one. And we do the training. We do a lot of training with emergency management folks, municipalities, and how to interpret all this information and what the threats are and all that. The other thing is we had two, prior to one, in the 10 years prior to one, we had 2 landfalling hurricanes in Nova Scotia. Since one, we've also had 2 landfalling hurricanes in Nova Scotia. So, in terms of what we're doing, I think we're preparing a news release close to the date of the 10th anniversary. That's about all we're going to be doing on the 10th anniversary of one.
The Pacific Coast, relatively from a weather perspective, relatively.
Yeah, they don't get these things up there just because. Just because the way that the winds blow in the tropics, that the storms won't curve up, and if you do get some kind of a tropical influence, the water is so cold that it you know, usually becomes something else before it actually reaches the west coast. Right?
Thank you.
Good.
Thank you.
I'm gonna be able to help you.
Well,